Okay, this is quiz 5A, and the idea is that we want to find the resistance. For the first question, what is the resistance from X to Y? In other words, can we simplify this network in a way so that we know if a current goes in here and out there, is there an equivalent resistance to as if it had gone, in X and went through an equivalent resistance like this and then came out Y. Okay, so the way, for X to Y at least, if you can think if current came in this direction, it's going to split and whatever, and anything that came out here, anything that split and went in this direction wouldn't impact it at all. So it's as if this guy is not even there. So the basic idea is we're going to, combine resistors in series and parallel until we get down to an equivalent resistance. So remember resistors are in series if the same current flows through the resistors, and and they're in parallel if the same voltage. Okay, so if we're going to go from X to Y, that means essentially Z and W are all just open circuit. So from the perspective of X to Y, the same current flows in this loop. So the 6 and 18 ohm resistance are the same. So these two resistors, essentially from X to Y, we'll have a 3 ohm resistor, and then we'll have the 12 ohm resistor, the 4 ohm resistor. So again, this is X, this is Y. And then we have another resistance here that is going to be 24 ohm resistance, which is the 18 and 6 ohm resistors in series. Okay, now we have these two resistors in parallel, so this becomes 3 ohms, and then we're going to have another resistance here, 4 ohms, and that'll be Y, X, 4 ohms, and this is, let's see, I'll do my little calculator here. We're going to do 12 times 24 divided by 12 plus 24, and oops. Okay, sorry. So 12 times 24 divided by 12 plus 24. Sorry, you can't see what I'm doing. Okay, and I get 8 ohms, and then of course these are all in series, and so from X to Y, this is equivalent to 8 plus 7, so 15 ohms, okay? And that's the answer here. Okay, now we're going to do what is the resistance from X to W. So it's like, having Y and Z open. So current flows, kind of split across here and out Y. Let me erase this stuff. And so we want to now find the resistance from X to Y. So this is equivalent to doing, we start with X, we go through a 3 ohm resistor, and then there's a 12 ohm resistor, and then, nothing would go this direction, so we can just ignore that, and the same thing with that direction. So we'll have the 18 ohm resistance, we'll have a 6 ohm resistance, and then this is W. Okay, so with respect to X and W, these two now are in series. So we would have, from X, this is equivalent to 3 3 ohm resistor, and then we would have a 6 ohm resistor, and then in this case we're going to have a 18 plus 12, so 30 ohm resistor, and then W comes out like that. And now these two resistances are in parallel, so we can, this is going to be equivalent to starting at X, going through a 3 ohm resistor, and then we have another resistor here, and then coming out W, and that's going to be 6 in parallel with 30, which is equal to, so if I come over here and 6 times 30 divided by 6 plus 30 gives me 5 ohms, so that's equivalent to an 8 ohm resistor. Okay, and that's the answer here. All right, so now let's do from Y to W. So here we're going to have, Y to W, and essentially we're opening circuiting X and Z, so we can essentially take that arm out and that arm out, and now we want to find the equivalent resistance from Y to W. So we start with Y. We have a 4 ohm resistor. There's a 12 ohm resistor here, a 6 ohm resistor there, and then an 18 ohm resistance there, and here's W. Now we notice that in this case 12 and 6 are in series. The same current flows through those resistors, and so this is equivalent to 4 ohm, and then we would have a 18 ohm resistor and another 18 ohm resistor, and then W, and so this is then going to be equivalent to a 4 ohm resistor, and now we're going to have another resistor that is going to be 18 in parallel with 18, which is equal to, so we do 18 times 18 divided by 18 plus 18, and that should be 9 ohm resistor, so that'll be 9, and then W, so this is equivalent to, from Y to W, to a 9 plus 4, or a 13 ohm resistance. Okay, so we get the right answer, luckily. And the last problem is to go from Y to Z. So when we go from Y to Z, again, we're going to just open these other guys like that. We're going to say, what's the equivalent resistance from Y to Z? So let's redraw this. We have let's see, so Y to Z, I guess I'm going to zoom out here for a minute. So this would be Y. We'll go through a 4 ohm resistor, and then we have 12 ohms, 6 ohms, and then here we have an 18 ohm resistor like that, and we've got a 5 ohm out to Z. Okay, so we actually see that current, whatever current flows. Let's see. Let me think about this for a minute. Anything that flows, any current that flows in that direction will come back out here. So anything that flows in here will eventually flow down that direction. So all of this is basically irrelevant for the resistance from Y to Z. So this is the same thing as a 4 ohm resistor and a 5 ohm resistor. and from Y to Z. So that it'll be equivalent from Y to Z of a 9 ohm resistor. Okay, so 9 ohm. Yep, that's the answer that's given here. Okay, so that's how to do quiz 5A.